Let's take a look at a cheap import Chinese CCTV power supply. This is the S1 2012, 120 watt I'd guess. It's a 9-channel output of 12 volt and it's 10 amps. I wouldn't ever use it anywhere near that. It is universal voltage, 120 or 240 volt, and it looks like this. So it's got a lockable enclosure for security reasons. It's got a little power LED to show it's active, and when you open it up, you have a switch mode power supply. You have a power switch inside, a standard European connector here, and you've got the 9 output channels, each with a little PTC thermistor to protect the output from overcurrent. And also you've got that green LED here. Let me show you the green LEDs by turning the light off and taking the exposure off, and you'll see the cute little green LEDs that show you the output is active. Watch your eyes, the light is about to come back. And it's back. So this is designed for controlling, well, it's designed for powering CCTV systems, but you don't just have to limit it to that. If I just grab, where is it, my LED strip here, you could use it for powering sections of LED strip. I've already hooked on a connector here, plug it in, and there we have rather motley looking purple neon type stuff. I'm not sure what power this takes. I'm not sure what power these little thermistors, these little things here, these little discs are PTC overcurrent sort of self-resetting fuses. Not sure what they're rated. What's quite interesting about this is that it comes with mounting hardware. It comes with the keys for locking it. It'll probably be quite low security. But it also comes with a load of spare PTC fuses. They shouldn't ever really fail. Why have they included 4 with it? Maybe they've had problems with it. But anyway, let's unplug this. And I shall turn this around like this so we can take a closer look at things in here. I shall zoom down a bit. Just knocking bottles of flux over here. The illumination is not great. I shall add some illumination. There's some illumination. So the first thing I notice here is that there's a little bit of flex going between the Euro connector and the terminal on board here. It is unplugged. This hinges up for access to those connections. They've got the live and neutral colours swapped here, but they do go to the right place. Live does actually go to the L, even though it's the wrong colour. There's a little on-off switch on board that switches probably 240 volt side, and rather disturbingly, live is green they've used here. Neutral's blue, that's nice, and the green, they've used yellow for the earth connection. I wish they'd used stand colours. There's also, I don't know if you can see this, a big splash of solder down here, bridging from, basically speaking, the sort of low voltage side to the high voltage side. Also there's a big splash of what looks like solder here. This is messy. Any of that solder coming loose and getting into the switch mode power supply would be an issue. On the switch mode power supply itself, we've got the usual arrangement there. With these, you've got a little potentiometer for adjusting feedback to the primary side of the switch mode power supply. But tell you what, I'm going to take this all out and we can take a look at the circuit board. So I shall do that right now. One moment, please. Okay, let's explore. And I have to say the isolation, the separation between the 240 volt side in this case and the low voltage side is not very good. Let me show you. So I've just taken a picture of one end of the circuit board and one connector because they're just echoed all the way along. And we've got the live, neutral and earth coming in. The earth goes along and goes via these pads onto the case for grounding, but it also goes to the switch mode power supply via a wire attached to here, and that also provides grounding via the switch mode power supply. The neutral goes straight out to the switch mode power supply, and the live goes via the switch to the switch mode power supply. But see this separation track here? It's just over 1 millimeter, and it's between the live and the negative going out to the CCTV cameras, and that's not grounded. The negative is completely separate from the sort of the chassis ground, or chassis ground if you prefer. It goes out, the live, neutral and earth goes out to the switch mode power supply, and I'll cover that in a moment. The switch mode power supply is a complex beast. It's really weird, but it's got the positive and negative coming back. The positive goes to a big bus bar running up one end of the circuit board. That's the positive bus bar running up here. And the negative one splits around these, almost like screening, but it finds a way around both sides to actually provide the negative connection to the output terminals. So the positive to the output terminals comes either via a fuse or a PTC thermistor. I've shown the PTC in the fuse position. It doesn't really matter, but basically it goes from the positive bus bar to the output positive terminal. And there is an LED and resistor across that, a very high value 2K resistor, and a gallium phosphide green LED, which is a very dim type, but it doesn't matter. It's very reliable and it's going to last a long time. There is a capacitor position here that's not occupied, and that is more or less it. It's worth mentioning that they've ringed round with that marker pen in two areas here, and they were both affecting. It's almost like during the testing phase, they saw that there were issues with this, and they were both affecting the solder joints associated with these thermistors. And I think because they've splayed the legs in these and then forced them in, I think they've stressed the legs of these, and that's why they've included spares, because it's possible that with the thermal cycling that these do in normal operation, that it's basically cracking them, and that's why they've done that. It's when I use these, when I put them into circuit boards, I'm very careful to form the leads. It would be ideal if the standard pitch of the leads was as the component is supplied, but sometimes to allow for variation you have to go a bit wider or to jump over a bus bar. And in that instance, like say for instance the Department of Villainy controller, I carefully formed the leads so that the components dropped in without stress. Other things worth mentioning, there is another 2K resistor going out to this connector. I appear to have pulled the connector completely off. Its pins, it's not separated correctly, but that's okay. Other things worthy of mention. The mounting holes, only two of them are what I'd call the right size. The others are really overly generous to the point that one had actually pushed down over the pillar because it was so big. And the reason for that is probably for the tolerance of when they go into the case, just to allow the fact they're kind of spot welded in the back, and there'll be a bit of tolerance, and otherwise they wouldn't be able to get the screws in. It's interesting. Oh, the metal oxide resistors are XF135. That's probably 1.35 amp. I tested it. I managed to trip it fairly quickly at 2 amps. And once it's tripped, the current drops down to 130 milliamps. The PTC thermistor fuses act like a slow blow fuse. They gradually heat up when overloaded, and when they reach a critical point, the resistance suddenly starts increasing, and because the resistance increases, they start heating up even more, and it causes an avalanche effect. You can suddenly see the voltage across them shoot up and the current go down, and then they reach that equilibrium point that in this case they've got about 12 volts across if it was a dead short circuit at 130 milliamps, and that's just enough to keep them warm enough to keep them in that locked state. Want to reset that, you turn the power off for a while to let them cool down and turn it back on again. If the fault is clear, everything will continue as before. Okay, I think that's me covered this. Let's take a look at the switch mode power supply. It is complex. It starts off straightforward enough. The incoming supply has it's got a fuse and a class X2 capacitor for filtering with a discharge resistor. It's got a common mode suppressed choke, a couple of class Y capacitors to the earth. It's got the bridge rectifier. I should zoom down this. Let's zoom in a little bit. It's got a discrete bridge rectifier, and then it's got a voltage selection switch between 110 to 220 volts, 110 volt to 20 volt. It's also got the NDC inrush thermistor. Is that marked? Yes, it is. NDC 5D11. That means, think that's 5 ohms default. Disc, D for disc, and 11 for the outer diameter. Let's try that. Let's get the calipers onto this. If I can. Yeah, 10.9 will do. That is about right. If I was closing up properly on that. It's a bit less than that, but it is roughly 11 millimeters diameter. So then it goes to, I'm going to have to draw this really. I shall draw it. But it basically speaking, there's a chip here for controlling this. And it is a 7500BD. And that chip is a standard switch mode power supply chip, but it's kind of being used very oddly here. It has its own power supply. It's in the low voltage side, separated from the high voltage side by this little coupling transformer. And it has its own auxiliary winding in this. And it almost looks as though when this unit starts up, the circuitry, I'll draw it. It's the best bet. Hold on, let me just do you a quick doodle of this. A doodle. So here's the incoming supply. I'll miss all the filtering. There's the bridge rectifier, drawn in a simple form. AC, AC, plus, minus. And the output from the plus minus would normally just go to the capacitors like this. So the two capacitors, oh, that's a positive, right? Okay, let's not draw it like that. This is negative. This is positive. This is negative. You're just going to have to ignore that half-assed capacitor there. And there's also balancing resistor across these. I would guess these are going to be rated 250 volts. They usually are, the capacitors, when they're being used like this. Not sure what the balancing resistors are because they're under shmoo. What are these rated at? 220 microfarad, that's quite high. And 250 volt, they are 250 volt, 220 microfarad, that's enormous. But there's an interesting thing. You've got the switch here for switching between the voltage. Normally, if that switch is open, I'll just draw this, I'll just jump it down here and it goes straight across one of the AC lines. So normally if that switch is open, and you have to be very careful to make sure, if you get a power supply that has the switch set to 120 volt and you put it across 240, it will go bang. It will cause problems with the power supply. So make sure it's set correctly. In this case, it was by default set to 220. And the only way to change it was to poke a screwdriver through the case and click the switch across. But when you click it across, it connects the AC to the middle of the capacitors. And then effectively it bridges out to two of the diodes become redundant. And the other ones, basically, this one is pumping this end positive and that one's pumping that end negative. And it's a voltage doubler and it increases. It means the 110 volt supply going in effectively creates the 220 volt supply. So the whole power supply is designed for 220 volts, and all it does is double the incoming AC supply if it's the lower voltage option. But then it gets a bit odd. The power supply is a capacitor. That's this one, and it looks, the circuitry suddenly starts looking like, and here's the primary winding, and then it goes through a feedback winding, and then it goes to two transistors. MJE, hold on, let me just, the transistors are very classic, 13007B. But those are standard NPN transistors, I believe, very common. And they have a feedback winding, and it makes it look as though this circuitry starts oscillating itself like a ballast, like a fluorescent ballast. And by pulling this alternately positive and negative, the capacitor decouples from the sort of midpoint of the capacitors, here the electrolytics, and it alternates the polarity through this winding, and then the feedback provides feedback via auxiliary windings. And then there is a separate winding. This is complex. I did not find a schematic for this. Certainly not one related to this chip. But it somehow exerts authority over what's happening on the other side. I don't know if it damps it or turns it off on demand. But this side has its own little power supply. And then the output from that push-pull effect goes to the, via a center tap winding. One side is negative, the other goes to this dual diode. Through the dual diode, the two sides of the dual diode, and then through a massive filter inductor, which is just the leads folded across. It's got two leads just common wound together just to make it easier to wind it. And then it goes to the gang of capacitors in the output. And the feedback is done by monitoring the output voltage. There's a little potentiometer here, but instead of some opto-coupled feedback, it's feeding back to this switch mode chip, which then exerts its control over the transistors on that side via this transformer. I really need to find a schematic for this, because this seems to be a common format. This chip seems to be used a lot in this style, but it's not simple. It's quite a wild power supply. Very interesting. I'm not going to reverse engineer this completely because that would take a very, very, very long time. That would be like when they copy the product in a Chinese factory, when they clone someone else's product. Now, there is one other test I want to do. There is a key on this. Caution, risk of electrical shock. Do not open cover. Let's lock it. And then do a bit of lock, pick and layer. That's it. It's secure now. Nobody will get into that. Where are my lock picks? There they are. Let's see how long it takes me to get into this. So here is the tensioning bar. And my favourite pick is this one. Right. So the pins are down this side. Okay. So I'm going to put my tensioning bar in here and put a slight tension on it. How long will it take me to get into... It's open. Right, okay. So it's not very secure. Let's try that again. That just seemed too easy. That was way too easy. I begin to wonder if you could stick a screwdriver in there and just open it. Right. It's locked. Tensioning bar. Just trim the pins. And it's open. Yeah, see, it's not secure. It's a cheap lock. But there we have it. It's got lots of flaws. Particularly like the fact they've just mixed brown and blue here. Other than that, you know, it's relatively interesting construction. Well, another thing, the power supply was actually screwed in from the end here. There were the screws going from various mounting positions on the outside. It's neat enough. It was cheap. I got it a while ago. It's taken till now to take it apart. I wouldn't use it excessive amounts of power. The only ventilation in this is a couple of slots, top and bottom, the right-hand side, and a couple on the left. But there we have it. The fairly interesting CCTV or indeed LED power supply. It was worth getting and certainly worth taking apart. Interesting construction, albeit that it was quite flawed and the electrical separation isn't really great. Other than that, very interesting.